Hey, good morning, afternoon, evening, whatever it happens to be, but we're talking ecology and we're talking ecology. And thanks again to Mr. Russell for putting together this presentation. And this presentation and this particular set of slides is all about niche and community interactions. And so you can see what our lesson objectives are for this short video in terms of getting a definition here, and then those roles that we have in terms of shaping what a community actually looks like, and then predation and herbivory, and then three types of symbiotic relationships. I think I might hold symbiotic relationships to another video. There's a lot that I can show with that, and there's some other video links that can go with that one. So I think I might just hit those first three bullet points really quickly. And keeping these videos nice and short, I don't like to linger, but you can pause at any moment and jot things down if you feel you need to. Please bear in mind that there may very well be an online digital final exam. Oh, we might be back in school. Oh, we don't know. We'll find out as time goes on. So if you need to pause here to jot some notes. There you go. All right. What else we got here? Let's see. So when we define the niche, and we talked about this idea of using the idea of tolerance. So all organisms have their ability to survive within these particular abiotic factors, whether it's temperature or pH, salinity, dissolved oxygen if you're an aquatic organism. That's going to have ramifications on the organism's ability to grow, reproduce, adapt, find food, escape predators, defined as fitness. You get all the ideas. And then if we go down to actually defining it, bullet point number 3 here, we have all of our physical and biological conditions in which that species will survive. So again, we're still talking evolutionarily fitness. The reason organisms end up into these niches is because of the adaptations that make them successful, allow them to escape their predators, find their food, and then pass on those genes that we've spent a lot of time talking about. The rest of it, I think, is fairly straightforward, so go ahead and click and choose as you need. Sometimes when we get within this idea of community interactions and this idea of niches, we get some competition. That's obvious. We're going to have organisms that are going to compete with each other for resources. And if those resources happen to be what we would define as limiting or limited resources, then we're going to have some significant competition that exists between those. That's going to limit population sizes. It's going to create adaptations. If we get some random mutations in there that makes them more successful, all the better we get. Sometimes if we have a direct competition within that niche and no one organism or both organisms can't survive within there or the resources can't support that, we get extirpation of the organism. So that would be essentially disappearing in a given area, or if all of them disappear, then we have extinction. So competition can lead to those types of ideas there. Also, competition is good. It's good. It's going to limit the numbers so that the resources are there. There's an author named Edward Abbey. If you are a reader, look up Edward Abbey, grab a book, grab your Kindle, grab your ebook, whatever it is, Edward Abbey. And one of the quotes from Edward Abbey that I always really enjoyed was that in the desert, there's plenty of water. There are too many people. So, and that kind of gives you that idea of a balancing act that exists within these ecosystems and within these niches that we have. So sometimes when we have this type of competition, we will get predation. Those are organisms that are going to predate on each other. And then we also get this idea of a keystone species. So in architectural building, when you're building an arch, you build the arch over, if you're building a bridge, like a Roman bridge over a waterway or something, you're going to build from one side of the bank, you're going to build from the other side of the bank, and then those arches have to line up perfectly. But even if you have it lined up perfectly, there's going to be pressure coming from the right, there's going to be pressure coming from the left, and so each of those arches needs some way to kind of balance against each other. And so we have this idea of a keystone, which is hard for me. It would actually be like that. It would be or like almost flat on the top and then linked down, almost like not a quite triangle, because this is not going to connect down here. So it's going to be something like that. And so the pressure then exists on both of those ideas. The keystone locks the arch in place. How does that apply to ecology? So when we have keystone species, It's the one that creates that balance within that ecosystem. If you get rid of a keystone species or you have an influx of too many of that keystone species, we can end up changing and altering the entire structure of that whole community and changing the ecosystem drastically so that we end up with an issue or a problem. Right. So, predator prey dynamics, this is old school stuff here. As we have a prey species is going to increase, excuse me, your predator species is going to come on behind there because the predators are eating the prey. We looked at this when we did natural selection with the bunny lab in my classes. I don't know if anybody else did that bunny lab. The wolf and bunny, where we changed it from the Arctic to the equator, and we saw the graph of how that population flows. So we get some standard J graphing that exists within predator prey dynamics between population sizes of those. I think that's pretty straightforward. You can interpret that graph. And then I'm going to pause right there because that's a good spot. That's a 6-minute mark. And we're going to stop right there in terms of our niche definition and our communities. So thanks, boys and girls, ladies and gentlemen, children of all ages.